Hello and welcome to this tutorial video. Today we create a model of a cyclic loading over the beam column joint in the steel structure, and we use the steel angle and steel stiffener as a welded joint to this beam and column. You can see this is column, this is beam, here a steel angle, and these are the steel stiffener. You can see it here. Let me click on this. This is the stress, and if I click on animate, see, this is the animation of the cyclic loading. You can see here at the load area we have buckling, local buckling in the beam. Also we have here at the middle of the simulation here, local buckling in the column. See here. And the deformation and stress, see the local buckling, see here. And deformation in the steel angle and stiffness at the bottom. The upper has a better situation. You can see local buckling here. See here also buckling. Let me use feature edge. See the deformation here. Okay, and this is the final view. See the deformation of the stiffener here and the low displacement here is buckling. See that the column, you can see column deformation. See that here, this is the deformation, and this is the buckling of the column. Okay, and this is the deformation. And now let me check, for instance, the ACL. The yield criterion first happen in the beam and column, and then in the steel angle and stiffener, and we use weld joint between this. They can be surface to surface interaction, constraint, or the weld joint, or the ductile damage. Here the damage here and here, plastic strain, displacement, or anything else, you know. You can check it also in this view. Now I'm going to draw the hysteresis diagram, which is the hysteresis diagram, the force displacement under this cyclic loading, and we use the hardening which is appropriate for cyclic loading, because in the cyclic loading we have changing in the yield surface, and in each cycle the stress strain remains in the material, and the Abaqus should consider that residual strain stress. So we should use a specific type of the hardening for the steel material. Okay, and this is the final frame. Let me draw the force displacement diagram here. This is the hysteresis diagram. You can see that in the H cycle, 2, 3, 4. And if I click on this, you can see the moving of the load and displacement in H cycle. So here you can use as the deformation of the stiffener. See this deformation. You can use uh, bolt instead this stiffeners and welded joint. we can use bolts to connect the beam and a steel stiffener and the column and the stiffener, and then we can do that. But in the static approach, the bolts and many surface interactions make some troubles for us, but you can use that. So if you need to model a steel structure with these connections under the cyclic loading, you can come to our website here, abaqusfm, abaqusfm.com. See www.abaqusfm.com, find the English tutorial here, click on the title or blue sign. Then you will have title, geometry, assembly here, a step interaction load, and then the result as figures. The cost for the CINP and English video file step by step is 26 euros. You can use a PayPal account, Visa or MasterCard for the payment. Before that, contact me to this email to get the payment link. We have also a full package here. The full package contains more than 400 tutorials. Almost they are advanced tutorial in all methods, in all fields. For instance, here explosion with all method for many materials, high and low velocity impact for all the materials, welding, biomechanics, forming, crack, everything. And the cost for this full package is so affordable for all people. So if you want to buy this full package to be mastering Abaqus in simulation and modeling, contact me to this email. Then I will tell you about the purchasing process. Thank you for your attention.